Hello again, everybody. I thought I would just do, just a straight up clean example, start to finish, something you'd be expected to do on a typical warm up. So you have f of x equaling 3x plus 2, going from 1 to 5. Couple little twists. There's two terms here instead of just the one. We're starting at 1 instead of 0. The good news is the strategy is still the same. We just got to break it down piece by piece. All right, so we know now that if I want an exact area, I'm going to take the limit as n goes to infinity of the sum of all my rectangles from 1 to n of my, I know that's my height and that's my base, so it's still base times height. And we just need to figure out, what is, the representation for my height? What's the representation for my base? So delta x we said was b minus a divided by n. So in this case, instead of 5 over n, it happens to be 4 over n. It doesn't really matter. That's my base. My height is f of x sub I, but in order to be able to get that, I just need my x sub I first. Well, my x sub I is my starting value, which in this case is 1, plus however many delta x's I'm going. So it'd be plus I delta x. Well, delta x we just said is 4 over n. So how many 4 over n's do you want me to go? I number of 4 over n's. Where am I starting from? 1. So to find my x sub I location, I start at 1 and I add in I number of 4 over n's. Okay, I know it sounds confusing, but that's all it really is it's breaking it down by how many rectangles out that you are and multiplying that by the base and then just adding your starting location. So f of x sub I means just take that x sub I and substitute in. So it's 3, that thing, 1 plus I times 4 over n. And that's not squared. Okay, it's just 3x. But there is a plus 2. So I got to just sort of account for that in my equation. 3x plus 2. 3x sub I plus 2. So my area then becomes the limit as n goes to infinity from 1 to n of this thing. I'm just going to clean it up as I go. This is 3 plus 12 over ni, right? 3 plus 12 over ni plus 2. That's f of x sub I. I still got to multiply by delta x, though, so times 4 over n. Okay, let's clean that up again. All right, so that's, 5, really, right? 3 plus 2 is 5 times 4 over n. So that's 20 over n plus, what's that, 48, 1248 over n squared I, 48 over n squared I. And those are all my pieces. So it's a little trickier. I mean, this part may look a little familiar, if you looked at the last example, but the 20 over n might throw us off. All right? So since this is just summation, I'm just adding stuff, right? This is 20 over n plus 48 over n squared I when I is 1, when I is 2, when I is 3, and you just keep adding. This is just addition as well. So I can actually break these two summation parts up and add them separately instead. And we'll find that's a useful technique when you've got more than one term. So I have I equals 1 to n of 20 over n plus, right? The limit still applies to everything. So it's plus the summation from 1 to n of 48 over n squared I. Okay? So now let's just focus on this part. Okay? This is the part that, threw some people off in class. Let's just talk it out again. 20 divided by n plus 20 divided by n plus 20 divided by n, right? I'm just going up my counter all the way until I do it n number of times. Well, 20 over n times n is just 20. Okay? What if it was, 2 of them? 20 plus n, here, I'll just write it out. 20 over n plus 20 over n is 40 over n, right? 40 over n is the sum when n was 2. Well, if n is 2, that's 40 over 2, which is 20. 20 plus n plus 20 plus over n when n is 2 is 20 over 2 plus 20 over 2, which is 40 over 2, which is 20. You could repeat this process for 3, 4, 5 of them. It doesn't matter. However many you have, you're just going to end up taking the 20 over n and multiplying by n, and you end up with the 20. So this whole thing right here, this part right here, will just go to 20. Okay, so what does that put us with? I still have a limit as n goes to infinity, I'll deal with that later, of 20 plus sigma from 1 to n of course I forgot again, 48 over n squared I. 48 over n squared I. Okay, so yes, the limit as n goes to infinity doesn't affect the 20. We'll have to deal with that over here. So I have 20. So far, there's definitely 20 as part of my area. So 20 plus, thank you, Pauline, the limit as n goes to infinity for this part right here. And once you get past that little hump of dealing with that, well, now it becomes a problem kind of like when we did the x squared. But this one is a little different. We have a different formula, so let's go ahead and just see how it works. This is going to be 20 plus, and let's see, the 48 over n squared is just a constant, right? If I is 1, it's 48 over n squared 1, 48 over n squared 2, 48 over n squared 3. It's a common factor to all the terms that we're adding together. So I'm going to pull that out for convenience so that I can deal with my new formula in isolation. Eventually, you'll get to the point where you could probably just do this part in your head, but I want to show it for all of you that are still trying to figure out. And by the way, I apologize for how awful my sigma notations are getting. I think the faster I try to write, the worse they get. I don't even know what that is. It looks like a paper clip, but whatever. Okay, not a paper clip, a staple. Sorry. That's how bad it looks. Anyway, so we have a formula for I, and that comes right off your cheat sheet. So we have our limit as n goes to infinity. 48 over n squared, and this thing becomes n times n plus 1 over 2. That's our formula for that. Let's take a second to rewrite it. Limit as n goes to infinity. 48 over 2, n squared plus n over n squared. Right? I did my little switcherooski. This 2 I just brought under here. Again, you can multiply it all through if you want. I'm just trying to save us some time. It's just switching the denominators here. You're still, n squared times 2 is the same. N squared times 2 is the same as 2 times n squared. It's the same thing. I'm just rewriting it for convenience. 48 over 2, of course, is just 24. That has nothing to do with the limit. So the limit as n goes to infinity of n squared plus n over n squared. And again, we can use our trick. So no, Chelsea, this is not 0. But the limit as n goes to infinity of n squared over n squared, or n squared plus n over n squared is just 1. So you get 20 plus 24, which is 44. Okay? Now, I think this one's kind of a good one for us to just double check geometrically. Okay? My original problem was essentially a line, right? It was 3x plus 2. Y equals 3x plus 2 from 1 to 5. Well, let's just graph that real quick. 3x plus 2. So 2 is up here, slope of 3, whatever, and I'm going from 1 to 5. So 1 to 5. It's just a trapezoid, no biggie. Trapezoid with a height of 4. My first base is going to be 3 plus 2, which is 5. My second base is going to be 15 plus 2, which is 17. So my area is going to be 1/2 base 1 plus base 2 times the height. My area is 12 divided by 2 is 6, which is, oh, that's 17. Come on, Pauline, where were you? 17. How about 22 divided by 2, which is 11, times 4, which is 44, which obviously we did a much more complicated way and still got 44. Granted, they're not all going to be lines. If this was that, we'd be in a lot of trouble. Okay, but for the moment, if it was linear, we could check it. Okay, hopefully this is enough for you to kind of get started. And if you're getting stuck on anything, please let me know. I'll try to re-explain it in some other fashion. But hopefully you guys will be in good shape. Okay, let me know if you need any help. I will talk to you soon, and that should do it for tonight. Bye.